The title on my presentation is Challenges and Future Activity. It doesn't work. Yeah, okay. So just as an introduction, you probably all know a lot about this and about what role snow has or can have in the polar region. First of all, it should normally cover 6 to 8 months the ground or the glacier in the winter in the Arctic. It's less and less valid currently. Of course, snow plays a big role on the glacier. That's the primary contributor to the mass balance of the glacier. But it also plays a strong role on ground. There's a lot of interaction with many, many different spheres: glacier, atmosphere, permafrost, and ground. And of course, any exchanges of matters, which can be either energy or impurity, has to go at some point through the snowpack during winter. Of course, there is many different areas of interest, more physical side on the glacier side. Also a lot of physical things happening on the ground, and especially rain on snow event and the amount of ice that can build up inside or under the snowpack. There is a lot of work done into impurity, whether it's long-range transport, but also local pollutants. And of course, there is many, many different means and ways to measure snow, from basic snow stakes measurement, but also using radar and snowmobile, onboard instruments, drones, helicopter, or UAV, whatever, and of course, remote sensing to get a much larger scale information. So all in all, there is many, many different areas we can work with snow and many things to do and to be done. However, what we see now and recently, it's a really sharp and quick decrease of the amount of snow in terms of snow water equivalent and in terms of coverage. In general, what we can see here in blue, that's the data from Longyearbyen. We lose on average half a day snow cover per year, which makes about 5 days per decade. That's a lot. It's a lot, and it goes faster and faster. And we do observe much more and stronger warming event with icing event, and particularly rain on snow event. As a direct consequence, of course, the mass balance of the glacier are more or less all the time negative. That's what we observe. Blue and green, these are data from Ny-Ålesund. That's the small glacier, typically similar to Longyearbyen. They have been starting to melt first and now even faster. And since early 2000, we start to have also a very strong and negative response from the bigger glacier, like Kongsvegen. And Kongsvegen, it's a decent glacier size for Svalbard. So all these data show us that the snow cover is decreasing, and this has a clear and quick effect. It is expected to decrease even more as snow and the cryosphere in general are responding quickly to the increase of temperature and the melting, but also to the change of the precipitation pattern. We do see more precipitation, but in the form of rain. The icing events are more present, and we do expect there will be more in the future. And of course, the structure of the snowpack is changing. And this is something I've been observing myself. It's been 3 years now I'm living here permanently, at least the entire winter. I've seen the last 3 years, 3 extremely different seasons. 1920 was extremely cold and dry. We have seen about half of the precipitation amount on the glacier. Combined with a warm summer, it made the record negative mass balance on the glacier in 2020. We have seen some sea ice in Kongsfjorden. That was 10 years we couldn't cross the fjord. In 20 and 21, it was about a normal season, never got too cold. We got a cloudy summer. we can say that this is about the kind of average season we do expect. And in 21-22, we got a normal snow cover, but in May, we got 1 week with extremely warm weather and rapid and quick melt in the valley. So all these seasons have different snow amounts, they have different snow melting, and that impacts many things in the climate, but that also impacts our activities. That also impacts the way we want to measure snow. And that also brings us a lot of logistical challenges. And the challenges we encounter in developing instruments on ground or on the glacier are mostly related to melt and icing events. And especially that if we look in the past, we could say that roughly 1 out of 5 seasons was showing strong melt. If we look on the last 10 years, that's about 2 out of 5 seasons show strong melt. 2020 was the record negative mass balance, and 2022 is number 2. And that is only for the last recent years. And of course, the melting and pose challenges in terms of accessibility, safety on the glacier. There is more open water channel. There is other activity going on, like for example, Kongsveien building a surge. There is things happening which impose us challenging. And we have to ask ourselves how to plan future activity considering these challenges. These are the data from Kongsveien, and we can see in blue that's the snow amount, in red summer melting, and in black the net balance of the glacier. We clearly see that already the recent years, it's quite a substantial amount of snow which is not coming on the glacier. We have way less snow and much more summer melt. And consequently, we can see on the last 10 years that a lot of the glacier have very marked negative mass balance. In the Infranord proposal, the original plan was to set up automatic weather station and snow station to measure continuously, also during winter, the snow amount in different areas, mostly located around Ny-Ålesund. The original plan was here in green to set up weather station in collaboration with the glacier people and Jack Collar, and in red, some snow station here and also here on Kongsveien. What we quickly realized is that these remote stations, are extremely challenging to maintain and even to operate. We had a lot of issue with wind smashing the station on the ground. We had issue with rime and station not collecting data. And in 16, 17, 18, and especially in 2018, we started to realize that Kongsveien is on the way to surge. So instead of deploying and insisting on this very remote area, we changed our plan and then swap the installation remotely there to focus on Midt-Rødvandbreen close to Ny-Ålesund. There is another reason around that. It's because on the last data we observed, we clearly see that those small glaciers are melting at a rate which is increasing, and that is something we want to capture. So this is also another reason why to move on the small glacier, to observe the effect of the snow and the amount of snow and the consequences on the mass balance of glacier, but also to capture an altitude gradient for the smaller glacier. And of course, we continue to focus on Kongsveien. And that is the current setup we have running. So we have 5 stations operating on Midt-Rødvandbreen and sending data through a LoRa network. So we have live data on that glacier. And we have 7, 8 stations on Kongsveien. And those ones are also on a network which is a little bit more complicated to operate, since we have to relay to Veivakhtaren and capture the 4G signal from Longyearbyen. But even if the data are not sending all the time, the stations are not sending all the time data or sometimes are stopping because they're out of battery, we still collect the data and we can get them afterwards. That is to say that even during the course of the project, after 2 years, we already adjusted our strategy. And the data, if you go on the science data portal, you will find them. The station, they are looking like this. They are basically mounted on a mass balance stake. There is a sonic range here measuring the snow height, and then that's the atmospheric temperature. There is a 3D wind sensor and an antenna, and then there is some extra battery, and the brain is in the box in the system. So this is mounting on a typical snow mass balance stake. It measures every 10 or 20 minutes. It depends on the place, and it depends also on the battery capacity, because we can put the station in sleep modus if we are running out of battery. Anyway, the lesson that we got and that we learned during the development of that of the station, that the maintenance of instruments on the glacier are getting more challenging. The area of interest can become less accessible in the future. And the strong melting can affect the data collection because of failure of the instrument, but also the quality. When the melting is very pronounced, then some of the stakes get unstable, and then the data collected are very noisy. These are many things that we do observe, and that we did observe during the collection of the data. But the current and the rapid changes will also affect our strategy and research priorities, as well as the data analysis, especially if we are thinking about more ice in the snowpack. This is, for example, 2019 season, when we had 4 days of rain in a row in Yellowstone. That imposed us a lot of challenges. We couldn't move out from town. But there is also other opportunity to do. We know now that since the climate is warmer, there is much higher probability for microbiology and bacteria to survive in the snow during winter. And that was something we did in December 2019. We did collect ice sample to look on the amount and microbiology inside the snow. There is prone, and there is some new challenges and some new interesting things that can be studied because of the warming as well. As a consequence of the role of snow on the climate in general and in Svalbard, it has been during the 2021 Polar Night Week, there was a snow workshop that was mostly online, if I remember. And then it has been suggested and led by the Knowledge Center and a group of snow researchers on different thematics to work on an agenda about future activity around snow. And 5 chapters have been developed and written. One about snow and glaciology, one about terrestrial ecology, atmospheric contaminant, remote sensing and modeling. And I'm going to present you the output of that work, which is going to be published in Polar Research very soon. It's maybe not exactly what you would like to do. These are suggestions, so it's open for discussion, and that's the purpose of the reason I'm presenting you this. We have been working on pointing out what we should focus in the future, but also what are the gaps and missing data according to us. In terms of glaciology, we do think that repeated transect and particularly latitude and altitude gradients are missing. There is definitely a need of new station, but as I presented, it's not always easy and it's costly in terms of maintenance, and they should be located at key and foreseeable accessible area if we do that in the future. We should also focus on data collection and the way we do collect the data to represent adequately the scale for remote sensing and modeling purposes. And of course, as presented yesterday also during the Cryos meeting, there is new technology that we may look into and use in the future, particularly GNSS techniques to collect snow depths and maybe a little bit later snow water equivalent. But in general, wet snow and rain on snow event and icy snowpack is one of the biggest challenges we are facing, and we definitely need to work on it. In terms of terrestrial ecology and permafrost issue, it mostly turns around the thermal structure and the physical structure of the snowpack, and particularly the ice content of the snowpack, which is related to the previous slide, and the thermal profile are definitely things which are missing. And also a better representability over Svalbard, but that is a challenging issue due to the logistic and the fact that drilling borehole in permafrost is demanding and costly. In terms of atmosphere, it's extremely large what is possible to do. However, it seems to us that deposition of contaminant, and particularly dust, is likely something that we need to focus in the future. But also how the meteorology affect not only the snow deposition, but also the source, long range, transport, also why not local emission of contaminant in the snow, and how potentially in the future the dust will affect even more the snow albedo. These are some questions interesting to look in. And of course, the post-deposition processes. This is something which is extremely complicated. And this is also something that is going to change in the future, especially by having water and ice inside the snow. In terms of remote sensing, there is products that have been developed, or we are working on products under the SIOS project. Some of them are focusing on the melt onset and the snow depths. This is something we are working currently to try to extract snow depth information using ISAT and focusing on land. I will come back to that. And there is, of course, a lot of different satellite products that can be used for snow cover. As mentioned, the key issue into this would be to scale the ground data and to work on the representability and variability inside a pixel for remote sensing. And for that, of course, ground measurements are still always needed, and snow water equivalent rain on snow event are currently the challenges we need to tackle. And of course, comes back to the current SIOS planet call, where there is a potential access to very high resolution images, which could also be interesting for us to compare with other satellite products. And finally, the last item we have been looking into it is the snow modeling. There is many different models existing. Some of them are more detailed than others. They have different way to work. They need different input data, but they also have different output. And the model you want to use depends on what information you are looking for and at what scale. But in general, what we have been finding out is the more complex and the more evolved and advanced is the model, it doesn't necessarily will help you to answer your question, especially on Svalbard. We figure out that the interaction between ground and snow is extremely challenging to run on Svalbard, particularly on land. However, there is modeling output, and it exists, but it's a constant work on progress, and we have to feed with field data and adapt the model all the time. And what we can see also as a result in the modeling, it's also an increase in the variability of the data, whatever is snow deposition or melting rate. So then the question is what to do in the future. Of course, I presented 5 different items. The pure snow people like me, focusing mostly on physical side, We're not going to develop all this work and research. It has to be in collaboration with the other people working in other sphere, atmosphere, and so on, and land system. However, to tackle the challenges that we have been observing in glaciology, now we are focusing on a snow pilot project, which basically aim on focusing on the gaps we outline in the agenda. It only concerns land system. We only focus on land. And we are developing a combination of camera, visible camera, GB camera. And that will be combined with GPR measurements on ground and remote sensing. And we will try to focus a lot on snow cover fraction, snow depths. We will try to focusing and continue to work on snow water equivalent, try to retrieve that, and work a little bit more on the ice content in the snowpack. There is also a wish, in general, we have observed that there is still a lack, even inside our community, of the harmonization of the collecting data and product. And this is, for example, what our Polish colleague did. They published recently a very nice paper about 30 years of snow data, which is now online and will be available. And that is maybe also something that all the different community should start to think about. There's not only the data we are collecting under SIOS, but there is also a lot of other data we do have, and maybe we should also dig them out, because that can be an interesting thing to have not only 5 years, but maybe 10, 20 years of data. The pilot study will focus mostly around the already equipped sites, which are near the Longyearbyen and Advandalen and Ånsund. The reason is that we have logistic facilities, we have people there, but we also have already a lot of data. And we have built that project from existing data we had and from experience we had using camera, for example. And this is something which have been done by Roberto Salazano from CNR, and working on the snow cover fraction using different information from camera and also from remote sensing data. And these are very promising data. And for example, using also on top of it some planet data with high accuracy, we can really start to work onto the variability inside the remote sensing data we can collect. So this is something we will continue. It's ongoing and will continue for the coming years. And of course, the main focus and what we are looking a lot into snow is try to get more information on snow water equivalent and snow depths. Those data are, there is way to get information, but it's still a work in progress. It's still challenging. It's much more easier to get the snow cover fraction. That is something we can routinely get from remote sensing information. And we are going to also to work on the previous data we have been collecting and work from season to season to focus a little bit more also on the variability inside each snow season. Because as I presented at the beginning, now it seems like every snow season or every season is a little bit different. So finally, we have also been working and outline in this exercise of publishing a snow agenda paper, a lack in general of coordinated protocols. And that is important for the repeatability of the data collection, but also the structure and the format of the data that we at the end need to publish on the SIOS portal. And there is definitely, in general, a very strong interest in working on the precipitation patterns, on the change of the amount and the type of snow. Of course, these are, as I mentioned, suggestions and open to discussion for future collection of data or research project, for example. So I'm going to stop here and just leave time for discussion if there is any or question. And this is the list of all the different people who contribute to all the different projects around snow under the Silex project. Thank you.